In the previous lectures, we looked at how stock returns might be modeled not just by a single Gaussian, but multiple Gaussians. In this lecture, we will begin to explore the idea that, in fact, there might be a time component to stock returns as well. Typically, when we model some random variable as a Gaussian, we think of each sample as being independent and identically distributed. But if there were a time dependence, that suggests that perhaps some characteristics of the stock return are predictable. So what is volatility clustering? Volatility clustering is the phenomenon we observe in stock returns, where high volatility returns are clustered near other high volatility returns. And similarly, low volatility returns are clustered near other low volatility returns. That is to say, if we've been seeing high volatility recently, it suggests that we will continue to see high volatility. If we've been seeing low volatility recently, it suggests that we will continue to see low volatility. And by the way, just so we're clear, let's assume that we measure volatility by the standard deviation of the return. At this point, we won't learn about any machine learning methods that will model volatility clustering, but the point right now is just to observe the phenomenon itself. So if we switch over to the code, we can observe volatility clustering simply by plotting the returns as a time series. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. So for this example, we're going to look at the same stocks we've been looking at for the past few lectures: Apple, Google, IBM, Starbucks, and Netflix. Basically, this code just does a for loop through all the symbols, and then we use the subplot function to organize our plot as a grid. Alright, so what do we see? Well, we can observe volatility clustering. So if we look at Apple, we see some high volatility here, maybe over here, over here. Looking at Google, here's some high volatility. Here's an area of low volatility. Here's an area of high volatility for IBM. And for Netflix, here's some high volatility. So basically, you're going to see clusters of high volatility and low volatility. High volatility follows other high volatility, and low volatility follows other low volatility. Alright, so that was a short lecture on what volatility clustering is. At this point, maybe you'd like to think about ways in which to model this phenomenon using machine learning techniques you've learned in the past.